In the world, there's two systems of measurements. There's imperial and there's metric. We use metric in Canada. Everywhere in the world uses metric except basically the United States. The United States is one of the few that still bases everything on imperial system. So miles, feet, inches, those are all imperial system. However, when we're talking about mathematics or science, we use kind of a modified of both. Primarily metric, but there are a couple situations in which we will look at the imperial aspect of it. But for us today, we are focused on what we call SI measurements. So you should have learned about this in grade 9 or 10 science if you're already there. System International is basically another way of saying metric. However, the units become inherently important in the SI units because there's a standard unit that you use to measure length, speed, time, and what's the other one I'm missing? Length, time, and distance. Distance. All right? All SI units are based on multiples of 10. The meter is the basic unit of length. Lengths can be measured with SI rulers, meter sticks, or calipers. A referent is an item that an individual uses as a measurement unit for estimating. When measuring, use an appropriate SI unit. Kilometers are appropriate for measuring large distances such as distance between cities. Millimeters are appropriate for measuring small units of length such as a plant's growth in 1 week. To convert from one SI unit to another, use unit analysis or proportional reasoning. Okay, so basically speaking, the first thing that we are going to do today is we are going to learn how to use proportions to change units in the SI system or the metric system. So I'm going to show you a method that isn't necessarily needed when you do simple conversions, but as the conversions get more difficult, for lack of better terms, more difficult, this is the best way to approach it. Okay? So the first thing we're going to do is we're going to just do a very basic one. So we're going to start with .900 centimeters. And I want to convert. So those of you that were in grade 9 science with me last year, you should be familiar with this already. Okay? So 900 centimeters. I want to convert it to meters. So I'm going to use what I call the proportionality that I know in order to convert it. So what I do basically is I draw a line. And on top I'm going to put, or whichever side I need it, I'm going to put the units that I want, and then I'm going to put the units that I need to get rid of. So, first things first, I want to change it to meters, and what are the units I want to get rid of? Centimeters. Okay? So then the second thing is, I want to put down the ratio of meters to centimeters. So what is the ratio of meters to centimeters?
100 centimeters.
1 meter equals 100 centimeters.
There we go. That's what I'm looking for. 1 meter is 100 centimeters. All right? And so I've created a fraction now, haven't I? So I multiply across the top, I multiply across the bottom, and then I divide when top and bottom can be divided. But 900 times 1 is 900, right? Then I take 900 and I divide it by 100. But at the same time, I cross out my units because I'm using the centimeters on top and the centimeters on bottom. And when I divide anything by itself, whether it's numbers or letters, they cancel and give you 1, correct? So what am I left with? I'm left with meters. So I take 900 and I divide it by anything that's on the bottom, which is 100. And what does that give me? 9 meters. Okay, yes, Brock.
We just do it like 1 meter, like graded differently than that.
No, not right now. You're going to learn this because I'm going to show you where it's going to be complicated and you're going to need to know this method. So if you, in your mind, know that there's 100 centimeters in a meter and you just have to divide, go ahead. But then the next thing I'm going to say is, okay, change 100 kilometers per hour to miles per hour. Not as simple, is it?
No.
So what I'm trying to do is I'm trying to show you how you want to approach easy ones so that the hard ones become easy as well. All right? So I'll come back to this guy in a minute. Let's start this again. All right, now what I want to do is I have 3.2 meters and I want to change it to millimeters. So the first thing that I do is I draw a line, and on top goes my units that I want to get to. So what are my units I want to get to? Millimeters, they go on top. What's the ones I want to get rid of?
Meters.
Meters. What's the ratio of millimeters to meters?
Divided by 1,000 to 1.
How many millimeters?
1,000.
1,000 over 1. Now, those of you that are looking at the sheet right now, and you're looking at it and you're saying, well, 0.001 or whatever, okay? Not in this case, but in this one there was, okay? Use the whole number proportionalities to help you. It makes it a lot simpler. Don't use the decimal ones if you can get away with it, okay? So basically, if you're looking in your workbook here, read. If you look on page, it's kind of index page 5. No, sorry, that's 9. That's 9. Okay? So find this conversion chart here. Based on 9. Okay, so you just go to the front of your book. Go to the front of your book. IX. Okay. All right, so everybody found it? All right, so looking at that, just look at the SI conversions there. So 10 millimeters in a centimeter, 100 centimeters in a meter, 1,000 meters in a kilometer. Those ones are the easier ones to do. They're easier for you to use. Okay? But let's keep going with this. So what do? I cancel my units because they're divided by each other, right? And so now I go 3.2 times 1,000. 3,200 millimeters in 3.2 meters. So far, so good? Yeah. Everything's okay so far? Like I said, grade 9, the ones that were my grade 9 science, we did this last year for sure. So I don't know if the other ones did it or not, but yeah, you have an idea.
Not in science, but in math.
Okay, good
Definitely
job.
not in science.
Okay, so here's the next thing. So let's do this again. Let's say I have okay, so I'm going to increase the difficulty of this right now. I want to change 28.4 kilometers. I want to change it into miles. So what's the first thing that I do? What do I do first? Draw my line first, exactly. And what are the units I'm looking for on top?
Miles.
Miles. And which ones am I getting rid of? Kilometers. So I make sure that they're flipped, right? So the kilometers are going to divide by the kilometers. Now, what is the ratio of miles to kilometers? Now use that sheet I handed out to you.
0.62.
Okay, you're going to have to say that so that I understand. There's what?
Like 0.62 miles in a kilometer.
No.
Is that on your sheet?
No, but that's, we were doing, what's it called?
Well, look in your sheet because there's a 4 decimal number in your sheet.
Yeah,
0.62.
0.62, that's on the sheet.
1.4.
Okay.
No.
Could you do 1 mile to 1.16 kilometers?
Yeah.
Oh,
I'm going to change that in a second. Okay? So there's 0.6214 miles in 1 kilometer. We got that? That's still on that page that I just told you about, not even the sheet, but the page. Okay? So now what do? I multiply 28.4 Because it's on the top, I multiply by 0.6214, and what do I get?
17.6.
3 decimal places, please.
17.647. Or 648, I guess.
Okay, got it round properly, that's part of this unit. Good. 17.648 miles. Now, I'm going to do this question again. How many kilometers in 1 mile? How many kilometers in 1 mile?
1.609.
1.609. All right, now, looking at this, what do I do with my numbers?
If you divide 20, it's 145, 1.
And 609. Yes. Okay. Again, I multiply on top, divide by the bottom. So right now it's 28.4 divided by 1.609. Punch it into your calculator, please. Get your calculators out. You're gonna need them all day. Brock, go ahead.
176.50.
No, I don't think so, Brock.
17.650.
My bad. I did something
Should it
wrong.
be the same answer?
Should be very close,
Yeah.
right? Okay, so now the importance of this. Both are right. You're off by 2 100ths, almost 3 100ths in this particular case. But how come? Because of rounding off. All right? This guy is a rounded off number, as is this guy. So ratio, like speaking about ratios, if I were to take 1 divided by this, I wouldn't get exactly 1.609, which I should in theory. Okay, yes, sir.
On this conversion sheet, it only says like 0.62. Where did you get the 1/4? Is there another paper?
Book.
Oh, it's a book.
Told you the page. Sorry. Okay. All right. Any other questions so far? Are we all comfortable with doing conversions right now? Yes?
Yeah.
Is there anybody not? Because I can do a few more. All right. This should be, like I said, the last unit, extremely hard. Oh, there. I'll come see you. The last unit, extremely hard. This unit is a lot more fair. Okay? So you have to make up for last unit's marks by sticking it to this one. Got it? Okay. There is one more thing I need you to look at. And that is on page 2.
Like actual page 2?
Actual page 2, yeah. And that's reading a caliper. Okay? Now, they don't ask you too often. Now, first of all, what do I see? What do I use a caliper for? A caliper is nobody knows what a caliper is?
Yeah. I've never heard that in my life.
Never what, sorry?
I've never heard that in my life.
Like a bridge calculator.
I think I have one in my closet. Let's see. I don't have one in here, so next best thing.
Is it in a geometry set?
No.
Yeah.
No.
Oh,
Yeah, still have never seen it.
No. Yeah. I definitely. It's typically one of those.
yes, they're in the shop. Okay, so there's some old ones in there, but I'm going to show you the ones that we are working at right here. Okay. All right, so this is a caliper. Now this is obviously a digital one. What it does is you see 2 tongs to measure. But what it allows us to, your centimeter ruler right now, for those of you who have a 15 centimeter ruler, you can only measure to basically the nearest millimeter within a plus minus of a half of the millimeter. That's how that works. This guy can measure within 100th of a millimeter or 1,000th of a millimeter.
Wow.
Okay, so that's what it's used for. It's used for measuring very small amounts. Okay, so what we need to do is we need to be able to read a caliper that is not digital. So that's what we're going to do right now. So look at the caliper that we have there. Okay. So this guy is a centimeter scale. So this is your ruler, your typical ruler. Now, on that ruler, if I ignore the little slider on the bottom, okay? I have 6 centimeters, right? And then I can see all the millimeters in there. So just like your typical ruler. So when measuring something, we have to, use the slider at the bottom to determine where exactly the numbers are located. So the first number that we are going to identify, we look at the scale on the bottom, and notice it says step 1 is pointing to the 0 on the bottom. According to the centimeters, which 2 centimeters is it in between? 2 and 3. So that means it's at least 2 centimeters plus. Okay? Now we look at that same 0 there, and let's find out how many tenths of a centimeter it is. So how many tenths of a centimeter is it? 2 plus a little bit, right? We agree? So then that means that I've got 0.2 centimeters as well. Anybody not see that? Put up your hand if you don't see that. Okay? So this line right here lines up. It's greater than 2. So that's the 2. And then I count the little ones. 1, 2. So it's slightly bigger than that 2. So it's 2.2 something. You follow now? You sure? Juan, you get it? Okay, 2.2. All right, now to find out the 100th position on this. Find out the 100th position. This is where it gets a little bit tricky. I look at the scale on the bottom and I find out which line is lined up exactly with one above it. Okay? So I'm looking on this little scale on the bottom, and I want to find out which is the first line that lines up directly below one of the lines above it. 0.3. It looks like number 3. That's where step 2 is. That's right, Jamie. Does everybody see where step 2 is pointing to?
Yeah.
So what does that tell us? It's 3/100ths of a centimeter. So what does that scale read then? 2.23 centimeters. Okay? Who does not understand that? Put up your hand. Which part?
Oh, I put my hand up to the first one.
So this 0. So I'm looking at the big numbers now. Where does it fall? Greater than 2, right?
Yeah.
So it means it's a whole number of 2. So it's 2 point something. You agree?
Yes.
Then I count the 2 little guys. So that means it's 0.2, right?
Oh, like.
Right, the 2 little ones right here. So 1, 2, and it's greater than that. So it's 2.2 something, right? And then I line it up here. And then I count it on this guy. 1, 2, 3. So what's the largest number? What's the largest number that I can have on that bottom scale there before I get to another whole number, right? So the largest possible number I could have is if that 9th digit lined up completely up with the last one. So the largest number I could have is 2.29 before it goes to 2.3. Do we follow? Like if this 10's lined up, it would be lined up exactly on 2.3, if that was the case. Okay.
When it's, where the 0 is,
Yeah.
it's not 0.3 away from the 2, it's 0.3 away from the 0.5. Like 2.5, you know what I mean? So shouldn't it be 2.22? Because it's 2 away from the number 2, not from the,
No. It's 2.2 for sure. You get that part.
yeah, for sure.
So now, if that thing is based on, it's somewhere between 2.2 and 2.3. That 0 is lined up somewhere between 2.2 and 2.3.
So, but like,
So then I'm saying it's 3/100ths in from 2.2. Right now, here's 2. 1, 2, 3. And my 0 is lined up right there. So what am I saying? This is 2.1, this is 2.2, this is 2.3. So I have to be between 2.2 and 2.3. Right?
yes.
Follow
Yep,
that?
I
Because
totally
it's in
follow.
between those two.
Yep, for sure.
Right?
Yeah.
So then it has to be a number somewhere between 0 and 9 in here. Well, what is that number? It's 3. And it's because this 3 lines up exactly with the number with the line above it. It's the first line on the bottom, and the line up directly with the one above it.
Like, I'll be able to do this work, but it just doesn't make sense that it's lining up with this way, when it no, I think it should be lining
No,
up.
it's because this 0 is here. So this identifies that it's between 2.2 and 2.3.
Okay.
All right? So how far in is it from 2.2 to 2.3? Is it 2.1 or 2.21, 2.22, 2.23, 2.29? It's got to be somewhere in there. And so it's based on whichever one of these guys lines up directly with the line above it. And that's what this scale does. Is it said that's how far it is in between those two. Yeah, even though it's lined up with the fifth one here,
Rather than this.
I have nothing to do with that. It's only this scale right here that I'm dealing with. Okay, so it's got to be somewhere in between 2.2 and 2.3. And so that little scale on the bottom, the lines line up. That's how you tell. Okay, so I expect there to be some difficulty with that. There's only 2 in this section that you have to actually do. It actually, unfortunately, gets harder for you when you do the imperial part, because it's on fractions. Okay, so there's a number you're missing tomorrow as well. So let's look at 2.2 right now.
We need videotape tomorrow.
No, I'm going to do it right now. Can I do that? And then you can get it. You can look at it tonight if you need to, but
You'll post it?
I can post it. Okay, key ideas. Imperial system now. I gave you an example of some imperial measurements. Inches, feet, yards, miles. So again, those conversions will be given to you. So now can you convert from inches to miles and so on? What is the point of imperial system for us? Where do you see us using the imperial system? Height?
Construction. Wait.
Height sometimes, yes. What was it?
Oh, construction.
Construction, right? Because what is a 2x4?
2 inches by 4.
It's a piece of wood that's 2 inches by 4 inches, right? It's not, what would we say, like 4.26 centimeters by 8 point some centimeters, right? We go 2x4. So we use construction, we use imperial for almost all of the stuff that we do. So we still have to know it, okay? The thing about imperial is it deals more with fractions. We deal with fractions instead of decimals. Metric, we use decimals. Imperial, we use fractions. So let's look at the example on page 6. Mary and Ling need to determine the area of a room they wish to paint. The room is rectangular with 1 window and 1 door. Mary measures the perimeter of the room to be 52 feet and the window to be 1.5 yards by 2 yards. Ling measures the height of the room to be 96 inches and the door to be 78 inches by 42 inches. If only the walls are to be painted, what is the area to be painted, measured in square feet. All right. So here is your question. First thing that we need to do is we need to find the area of the four walls. Okay? So the perimeter of the room is 52 feet, right? She measures the height of the room to be 96 inches. So how do I find out what the area of the wall is?
If you divide 52 by pi, you don't get just the diameter, and that would be like the length of the.
Well, we're not talking about a circle, but you're very close. Do I do what?
Divide 52 by 4.
Yeah, right? Because it's a square, right? So the perimeter of this square is 52. So x plus x plus x plus x is 4x, and 4x equals 52. X is equal to 52 divided by 4. Deck of cards, deck of cards, take the deck of cards. How many? What is it? Right. 13 feet. Now, one wall. There's 4 of them. One wall then is 13 feet by 96 inches.
So change the feet to inches.
Okay, so now that would be my choice too, Brock. But the question asks about square feet. So we want to change 96 inches to feet. So what's the conversion?
Divide by 12.
Feet to inches. 1 foot is
8.
12 inches, right? So I divide by 12, which gives me 8 feet.
I thought it was 13.
The one side is.
4.
The.
This wall is 13 feet by
Oh.
96 inches.
Okay.
Okay, so now, what's the area of that guy then? 13 by 8. And how many of them do I have? How many walls? 4 walls?
416.
What is it?
416.
416 square feet, right? All right. Now, we have to subtract what from it? Windows and doors. How many windows are there? 1 window. And what's the dimensions of that window? 1.5 yards by 2 yards. And again, what do we need to do with the conversions? So how do I convert yards to feet? Times it by 3. Very good. So that gives me 4.5 feet here, agreed? And 6 feet here. So the windows dimensions, the area of the windows, 27 feet. 4.5 by 6, 27 feet squared.
That's the windows.
There's just one window?
That's the window.
Don't have to.
How many windows are there?
One.
1 window, 1 door. So now I gotta do the door. Okay, what's the dimensions of the door now?
78 by 42.
So 42 inches down here, and 78 inches here. I have to convert. So how do I convert again?
42 times
Divide by 12. What's 42 divided by 12?
3.5.
What is it?
3.5.
3.5 feet. What's 78 divided by 12?
6.5.
6.5 feet. What's the area of the door now?
22.
75
Yes.
feet squared. How much paint do I need? Rex?
366.
0.5?
0.25.
0.25 feet squared. Right? What's wrong? We're good?
I think.
How many of us find this better than the last unit?
Oh, yes, wow.
I like this.
Shocker.
Shocker.
Okay.
I love that.
So you have for Monday, you need to complete 1-1 and 1-2. Okay, so you have the rest of today, still about 40 minutes. And then you have all day tomorrow for those of you that are here. Got it?
Do we have to use a caliper for metric? Sorry, Imperial?
You'll get into that. But
But
not yet.
not yet, okay.
I'll do that with you on Monday. That's question 3. You can see if you can get it. So that's question 3. Okay, go to work then.
Los
Right now,
muchachos,
please.
estas libras tienen la conversión.
Just a second, I just took the camera off.
Apoyado. Antes de la mesa.
Thank you.